For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@excelhomeworkhelp.com or reach us at www.excelhomeworkhelp.com. Bulmer exercise 2.1. When you are calculating conditional proportion, or probability, your SAM-PLE space differs from that of marginal or joint proportions. For example, when it is conditioned by 6 on white die, only the sample size of 6 on white die, here, therefore, 3932, is a sample set to be considered. That is, the denominator of a probability completely changes. Based on this fact, calculating conditional probability yields, A. 3 on red die given 6 on white die equals 629/3932 equals 0.16, B. 5 on white die given 4 on red die equals 509/2916 equals 0.175. Both of A and B are different from marginal probabilities of 0.159 and 0.182 respectively. Although not perfectly same, marginal probabilities and conditional probabilities are very close. Since this is a rolling a die game, two events of throwing of a white die and a red die should be independent. Moreover, if two events are independent of each other, we expect that a marginal probability is same as a conditional probability. Why? Recollect that if A and B are independent events, joint probability of A and B is simply a production of A and B. Therefore, excelhomeworkhelp.com. Thus, when two events are independent of each other, a conditional probability is the same as a marginal probability. Bulmer exercise 2.5. The sample set here is all dates in a year. Therefore, there are 365 days to choose in a sample set. We ignore a leap year with 366 days here. First person has all 365 days to choose as his birthday. His probability of having a specific birthday will be always equals 1, since he can freely choose any 365 day. 1. When no one shares the same birthday, the choice set left for second person only contains 364 days. Therefore, his probability of choosing any day except for first person's birthday is 364/365. In the same way, the probability that third person's birthday is not same as first person's nor second person's is 363/365. The probability of three events are happening together is a 364/363 production of each of three probabilities. 365/365 times 365 times 365 is equal to 0.9918, When two people share the same birthday, first person choose any day he wants, so his probability is 1 again. If second person's birthday is the same as first one, he is only able to choose the same date for his birthday as first person's. Therefore, his sample set contains only one date, which is first person's birthday. Therefore, his probability is 1/365. Lastly, third person is left with 364 days, which are different from first and second person's birthday, to choose. Therefore, his probability is 364/365. Now, the joint probability is 365/364 equals 0.0027. We should consider there are three. excelhomeworkhelp.com. Birthday sharing 365 times 365 times 365 pairs out of 3 people. So, multiplying the joint probability by 3 yields 365/364/363/365 times 3 equals 0.0082. 365 times 365 times 11, 3. The probability of all 3 sharing the same birthday is 365/365 times 365 times 365. Since both second and third person's sample set only has one date, which is first person's birthday. Bulmer problem 2.3 pairwise independent if P, EI and EJ equals P, EI times P, EJ for all I equals J. And mutually independent if P, E1 and E2 and N equals P, E1 times P, E2 times P, N for all 1 is equal to 2N. The probability of first die and second die to have an odd number is 1 for 2 both. Also, the probability of having an odd sum of 2 dice is 1 2. Page 20, Table 4. Apparently, having an odd number on first die is an independent event of having an odd number on second die. The table for the combinations of 2 dice follows. Table of die combination: first die, second die, sum of 2 dice. Odd odd, even odd, even odd. Even odd odd. Even even even. excelhomeworkhelp.com. As the table shows, the probability of having an odd number on first die and an odd number on second die is 1/4. Note that there is only one case that satisfies this out of 4 cases. And the probability of an odd number on first die and an odd sum of 2 dice is also 1/4. Lastly, the joint probability of an odd number on second die and an odd sum of 2 dice is 1/4. If pairwise independence exists, joint probabilities should be the same as the product of events probabilities. Therefore, 3 events are pairwise independent. In the same way, mutual independence should satisfy. As shown above, the joint probability of E1, E2, and E3, which is 0, is not the same as the product of 3 events probability, 1/8. Thus, they are not mutually independent. And this suggests that pairwise independence does not guarantee mutual independence. excelhomeworkhelp.com. Bulmer exercise 3.4. In order to solve this problem, I would figure out marginal probability first, then conditional probability and joint probability. The key point of the question is dependence of 2 variables. Unlike previous questions of independent cases, X and Y here are definitely dependent of each other, since Y is determined by X. Since a probability for any X is equally distributed to -1, 0, and 1, PR, X equals -1, equals PR, X equals 0, equals PR, X equals 1, equals 1/3. Y can have 2 outcomes of 0 and 1. The marginal probability of Y is conditional probability of XS given YS are PR, X equals -1, Y equals 0 PR, X equals 0, Y equals 0, equals 1 PR, X equals 1, Y equals 0 PR, X equals -1, Y equals 1, equals PR, X equals 0, Y equals 1, equals 0 PR, X equals 1, Y equals 1, equals 1/2. The joint probability can be calculated using conditional probability and marginal probability. Recall that event A and B's joint probability is PR A and B equals PR A B times PR B equals PR B A times PR A. excelhomeworkhelp.com. Inserting what we know already into formula above yields PR, X equals -1 and Y equals 0, equals PR, X equals 1, Y equals 0, times PR, Y equals 0, equals 0 times 1/3 is equal to 0 PR, X equals 0 and Y equals 0, equals PR, X equals 0, Y equals 0, times PR, Y equals 0, is equal to 1 times 1/3 equals 1/3 PR, X equals 1 and Y equals 0, equals PR, X equals 1, Y equals 0, times PR, Y equals 0, equals 0 times 1/3 is equal to 0 PR, X equals -1 and Y equals 1, equals PR, X equals -1, Y equals 1, times PR, Y equals 1, is equal to 1/2 times 2/3 plus 1/3 PR, X equals 0 and Y equals 1, equals PR, X equals 0, Y equals 1, times PR, Y equals 1, equals 0 times 2/3 is equal to 0 PR, X equals 1 and Y equals 1, equals PR, X equals 1, Y equals 1, times PR, Y equals 1, is equal to 1/2 times 2/3